Hello, class. Today we're going to start on section 2.7 and also 2.8. Now, 2.7 is on pages 241 through 243, and is 1 through 5 odd. And then section 2.8 is on pages 248 to 252, 1 through 9 odd.
I
Now,
don't think it's recording.
you say what, Alea?
I don't think it was recording.
Oh, it is recorded. I use Snagit. I don't use a Big Blue Button recorder.
Okay, sorry about that.
Oh, no problem. Well, I'll just say this. The reason why I use Snagit and I'll put this out here is because if you notice, the recordings are a lot bigger because Big Blue Button recordings are kind of like a little small. Did you all notice that on YouTube, that the recordings are a lot bigger than what you see in the class?
Yeah.
Okay, yeah, that's why I use Snagit and I use another screen to record it. So yeah, but thank you, Alea, because if I was using Big Blue Button, I would have really messed up if I was going through all of this. Okay, now for 2.7, I'm going to cover problems 1 and 5. Problem 3, you will do on your own. And then for 2.8, well, when we get to 2.8, I'll go over the problems I'm going over. Okay, so first of all, problem number 1. We have two. Let me do these tables real quick. So we have x, and then y equals f of x. And then we have the other table. Then we have x, and then y equals g of x. Now, since we're doing this right now, let me just say this. Whenever you see f of x, g of x, h of x, or anything of x, that is really representing y. So when you see that, that's the same thing as saying y is equal to those values. Okay, so let me put this here. 5, 7, 9, 2, 4, 6, and 8. All right. Now, so we have 1a. Now, a, they want us to do f of g of 7. Okay, so first thing we do here, we go to G. This is the G portion here, and we go where x is 7. When x is 7, g of x is equal to 6. So this will end up becoming f of 6. Now we go over to the f portion. We look at the x value when x is 6, and then that 7 is our final answer. So our final answer here is 7. Okay, now we do B. B, we have G of f of 4. So we go to the f portion, and we go here where x is 4. So then the y would be 5. So this will end up being G of 5. So we go here where x is 5 under the G portion, and your answer here would be 4. Now we go to C. We have f of g of x. Now, f of g of x, we have g, we go to the G portion. Now, f of g of x, now what is g of x equal to?
G of x should be x.
Okay. Well, doesn't it tell us that g of x is equal to y?
Yes.
Okay. So this would be f of y, right? Okay, so if g of x is equal to y, so then if you look here, f of y is actually equal to whatever your x value is. Because remember, if we go in here and we substitute in the y value from the f, isn't it going to give us an x answer?
Yes.
Yeah, so that's just a roundabout way of finding x. And it's the same thing when you get to D. It'll be g of f of x. And we know f of x is equal to y. So this would be g of y. And what this is saying is whatever you get for y, your answer is going to be x. So that's basically it. All right, that took care of 1. Now 5, woo, 5 have 9 parts to it. It says, this is on page 243. It says, you are now familiar with the conversion tables in exercise 4, but you would like to be able to take any amount of money and convert between US and Canadian currencies. First, verify that the functions f and g in exercise 4 are linear. Then refer to the data in the tables to answer the following. Okay, first of all, we got to go back to problem number 4. Now, I'm not going to write out problem 4. I'm going to put it in the table over here. Now, in the table here, the x values, wait a minute, amount of you, okay. If you look at problem number 4, the amount in US dollars is your input, which is the x values. Now, number 4 is on page 242. So the amount of US dollars is your input, which is your x values. The amount in Canadian money is your output. So we know for our x values, we will have 50, 100, 250, 500, and 1,000. Okay, next, the y values. We have 63.13, 126.27, 315.66, 631.33, and 1,262.65. Okay, now we have our table here. Let me stretch this out a little bit so we can see the table a little better. Okay. All right, so I stretched this out a little bit, so now we can see the table a little better. All right, so now we have our values in the table. So we could go back to problem number 5, and it tells us to first verify that the functions f of g in exercise 4 are linear. Okay, so now the first of all, the f function, oh, okay, I see what they did here. Okay, so first, let's just do the f function because that's what we're given first. Let's just do that first. All right, so the f function here is the points that we put into this graph here, which is, and just to give you a visual representation, since you all have the textbook, this right here sits right above 4a. It's the graph right above 4a. So now what we could do here, remember how we did the linear function where we had y sub 1, and then we did the tilde, and then we had mx1 plus b. Now, if you see here, our r squared and our r is equal to 1, which means that it is a perfect line. It's linear. Do you all follow that?
Yes.
Okay, so now they give us the slope and they give us the y-intercept here. Okay, with that being said, with a, 5a, the slope for the f function is 1.2628 if we round to 4 decimal places. That would be the slope for a, which is dealing with the f function. Now, it says, what is, and we're going to get to the G in a second, but let's go ahead and answer all of the F portion first. Okay, B, it says, what is the practical meaning of the slope in this situation? Basically, takes 1.2628 Canadian dollars to equal 1 US dollar. So that is the practical meaning. So it takes 1.2628 Canadian dollars to equal 1 US dollar. Okay, so now we go to C. Now C, it says use X to represent the input amount in US dollars to write the linear equation of the function f. So we have f of X is equal to 1.2628x because we do not have a y-intercept, because when X is 0, if we have 0 US dollars, it's going to be 0 Canadian dollars. So, and you could look here too. When you see this B here, I mean, technically, if we round it to 4 decimal places, technically we would have a y-intercept, but it's so low that we might as well say that it's 0. Does everyone follow that? Okay. All right. So now we have C. Now we go to D. Now D, it says use the equation to determine f of 3000. Explain the practical meaning of this situation. Okay. Before I find out, before we put in what, well, let's put it in. So we would do 1.2628 and then times 3000. So that would give us, so we could say f of 3000 is equal to 1.2628 times 3000, which would give us 3,788.40. Now, basically the practical meaning is this here. If you have 3,000 US dollars, it is worth 3,788.40 Canadian dollars. Oh, Brianne, did you have a question?
Oh, I didn't. No,
Oh,
sorry. I don't
okay,
know
it's no
why
problem.
that did that.
It's no problem. Okay, so now this took care of the F portion of the problem. Now we're going to get into the G portion. The G portion, as far as I could tell, is just basically the inverse. Basically, we're going to do the Canadian dollars be the input, and then the US dollars be the output. So basically, we're turning this around where Y becomes X and X becomes Y. So we're going to do another table. And then now X would be the Y values, which would be the 63.13, the 126.27, the 315.66, 631.33, 1262.65. And then here we have 50, 100, 250, 500, and 1000. Okay. So now we have our values. This is basically the inverse. If we scroll in here, you see we have our points here. Now, what we could do, we would do this the same way as we did the beginning problem with the y equals mx plus b. But if you notice here, we had x2 and y2. So we would do y2 and then the tilde, and then we would do mx2 plus b. Now remember, we only want to look at the line that we have here, which is this red one. So we could turn off this black line by clicking on it, and now the black line is gone. So now we can see that this is a straight line, or you can look at the correlation coefficient, it's a +1. So we know that that is linear. So now when we get to E says determine the average rate of change, the slope. Now, we already have the slope here. They tell us to round the slope to 4 decimal places. The slope is given to us as 0.79. Oh, I guess it has to be 20. That's when we round it. It'll be 0.7920. Okay, so now we go to F. Oh, I'm sorry, I did one thing that I shouldn't have done. I should have put the M and then an approximation sign to show that this is the slope, that that's an approximation. So that's E. Now we want to go to F. It says, what is the practical meaning of the slope in function G? So basically, you have 0.7920 US dollars for every 1 Canadian dollar. So that is the practical meaning. Let me see if I can move this over a little bit. Oh yeah, that's good. Okay. So this is actually F. Now we go here to G. It says use X to represent the input to write the linear equation of the function G. So it'll be G of X is equal to 0.7920. And as you all can see here, that we have just as small as a y-intercept as we had for the F formula. So we do not write the B, and that'll be X. Okay, now for H, use the equation to determine G of 6,000. So we have G of 6,000 is equal to 0.7920 times 6,000. And let's see what that answer is. 0.7920 times 6,000. So this would be $4,752. Well, actually, it'd be $4,752. So the practical meaning of this, if you had 6,000 Canadian dollars, it is equivalent to 4,752 US dollars. Okay, now we have I. It says prove that the two functions are inverse functions by showing that f of g of x is equal to x and g of f of x is equal to x. Round your calculations to the nearest whole number. All right. So we have f of g of x is equal to f of, we see that g of x is equal to this amount here, 0.7920 x. So that would equal to, now, remember before we had on the previous page, what f of x was equal to. F of x was actually equal to, wait a minute, oh, down here. F of x is equal to 1.2628x. So what we would have is 1.2628 times the parenthesis of 0.7920x. Now, when we multiply this, of course, this is going to be an approximation, but if we take 1.2628 and then multiply it by 0.7920, you see that it has 1 in all of these zeros, so it's approximately 1. So this would be approximately 1 times x. So this would approximately equal to x. Does everyone follow that?
Yes.
Okay. And then finally, we have to do g of f of x. So we would have g of 1.2628x, because f of x is equal to this. And then we know g of x is equal to this here. So it'll be 0.7920 times the 1.2628x, which is giving you the same amount here. So this will be approximately x. So we proved that. So now, we just finished up section 2.7. Now we're going to go to 2.8. Now 2.8 starts on page 248. And we're going to do, now I'm already going to do 7 and 9, but I'm going to pick up one more. Let's see. 7, 9. I think I'm going to do 3. Yeah, so I'm going to do problems 3, 7, and 9. All right, so number 3, and this is on page 249. We have 3a. We have y is equal to f of x is equal to 3x minus 4. It says determine the equation of the inverse of the given function. So they want us to write an inverse here. Now, personally, when I write inverses, I usually don't use the f of x until I get to the end of the problem. So right now, my concentration is going to be y equals 3x minus 4. Now, to do the inverse, what I would do with that, the x and the y would change positions. So y would become x and x would become y. Now, we're going to solve this for y. So we would add 4 on both sides. So it'd be x plus 4 is equal to 3y. So now we got to get rid of this 3 off of the y. So we could divide each side by 3. And you will have y, I just turned this around, is equal to x plus 4 over 3. Now, to rewrite this, we'll rewrite this as f inverse of x is equal to x plus 4 all over 3. Now, in some books, they also include and have y equals, but typically you would see it more so in this form. All right, now we go here to 3b. It says w is equal to g of z, which is equal to z minus 4 all over 2. Now again, I just write w is equal to z minus 4 all over 2. Now we would switch places with the W and the Z. So this would be Z is equal to W minus 4 over 2. Now in this case, we need to get W by itself. So I will multiply each side by 2. So this would be 2Z is equal to, these 2's will simplify out, and this would be W minus 4. We add 4 on both sides, and we have 2Z plus 4 is equal to W. So this is really W is equal to 2Z plus 4. So now we will have G inverse of Z is equal to 2Z plus 4. Now you can write the W equals there as well. Now, last but not least from this page would be C. Now C is S is equal to 5 over T. Now, we switch places of T and S. So this would be T is equal to 5 over S. Now we need to get basically we need to get S by itself. So we have to multiply everything by S. So this would be S times T is equal to, these S's will cancel out and leave you 5. So we'll divide each side by T, and S is equal to 5 over T. Now we can leave it like this because what I noticed in the answers in this book, they do not put the inverse with the singular variable. So this would be the inverse of it here. Now, just in case, because I don't know if my math lab is in sync with this or not, but if you ever encounter this, since this is the inverse, a lot of times you will see it written like this. So I'm just letting you know that these two are the same because this was the inverse. So just so you all will have that in your record. Okay, now we move on to problem number 7, which is on page 251. So we have 7a here. It says given g of x is equal to 6 plus 4x over 3. Determine the equation for g inverse of x. Okay. So we have 7a, and we have g of x is equal to 6 plus 4x over 3. And we want to get g of x. So now what I would do is this here. I'm just going to make g of x y, and then I would make my changes at the end. So I'm going to switch x and y. So yeah, x is equal to 6 plus 4y over 3. Now we need to get y by itself. So we can multiply everything by 3. It'd be 3x is equal to 6 plus 4y. We can subtract 6 on both sides. And we add 3x minus 6 is equal to 4y. Divide each side by 4. And you add 3x minus 6 over 4 equals y. Now we're going to write that using g. So it'll be g inverse of x is equal to 3x minus 6 over 4. So that is the inverse. Now, one thing I need to stress here. I know this 6 and 4 can be simplified, but the only way that we would usually break this up, sometimes we do, but most times we'll break this up if both of these terms have something in common with the 4, which they don't. Okay, now we go to B. It says sketch a graph of G and G inverse on the following grid. All right, listen. I'm going to put this in Desmos because I think it'll be better served being in Desmos as opposed to me drawing this. Now, you can draw this at your leisure, but looking at this in decimal, I think will give a better visual picture. So we'll go here, we're at our table, and then first we'll do the g of x. Oh, actually, no, we won't do a table. We'll do the equation. So g of x, we have y is equal to 6. Then we could do divided by and go back up. So it'll be 6 plus 4x in the numerator. And then we had 3 in the denominator. Okay, that's one line. Now we go here to the inverse. The inverse, we'll still put y is equal to. Then we add 3 divided by. Then we'll come back up here and put our x minus 6. And then in our denominator, we will have 4. And you see we have our two values here. Now, if we stretch this out, because you see I'm more so in the 50s and 100s, but on your table, you may go down to maybe about, the 5s, 10s, or something like that, where you won't see the intersection, but we do see the intersection point here, which is -6, -6. Okay, now, it says, do you believe, this is C. Let me shrink this up a little bit. It says, do you believe that your equation for G inverse in part A is correct? Explain. Okay. I would say yes. And the reason is because the graphs are reflections in the line y equals x. Now, if you want to prove that, and this is where Desmos will come in handy again, we could go up here to this wheel, do a table here, and then I'm going to do a table here. Okay. I want to do a table here as well. Okay, now, reflection, if you look here, they do have a couple things that is a little different here, but they do reflect across this line. Let me see something here. All right, let's go here. Because they ask, are they inverses of each other? So basically, let's take a look here. Where x is -2, we will have to put this value in down here for x. Let's put in -0.666666, and then we could put 7, and you see that it's -2. Or we could do this. We could put, you have 2, 0. Y became x, x became y. And then we have, let's try another number here. Let's do negative, let's see, this is 3 point. Let me see if I could put in some more numbers here. Let's do 5, 7. All right, let's do 9. Okay, 9. So then that means that if we put in 14 down here for x, that would mean that your y should be 9, which it is. And then we could put in, let me just try one more number. Let's try the number 12. Put in 12, 18. So if we put in 18 down here, it should give us 12, which it does. So it shows the reflection here. All right. So now we go here to D. It says determine G inverse G of X. Does your result support your answer in part C? So they want you to actually physically do this. So we have D. So we have G inverse. And then we know is well, let me just put that here, g of x. We know g of x, as we discovered up here, g of x is 6 plus 4x over 3. So it'd be g inverse of 6 plus 4x over 3. Now we have to look at the g inverse, which we have here, which is 3x minus 6 over 4. So we would take 3 times 6 plus 4x over 3 minus 6 all over 4. So when we do our numerator here, these 3's will simplify out, and you have 6 plus 4x minus 6 all over 4. Now 6 minus 6 is 0, so this will give you 4x over 4, and these 4's will simplify out and leave you x. And then your answer would be yes, because g inverse of g of x is equal to x. All right, now that took care of number 7, and now we need to do number 9. Okay, number 9 is on page 252. It says your new kitchen has a square island that needs a granite top. The side of the largest square top you could purchase measures s equals f of a equals the square root of a, where s is the length of the square in feet and a is the area of the square. Using a graph of s, sketch s inverse. Do this for the general function, ignoring the context of the situation. All right, so we had s is equal to f of a, which is equal to the square root of a. So they want us to graph s, and then they want us to sketch the s inverse. Okay, we're going to use Desmos. I want to get rid of all these other graphs so we won't have a problem here. Now we know that we could put y is equal to, and we would do the square root of x. Okay, so now that is our beginning value. So we have some options here. We could either go through and do the inverse function. Well, let me do that since we just did it. And then I will show you all how to do it in Desmos. So basically, we'll make this y equals the square root of a. We'll switch positions of both. A is equal to the square root of y. And then what we would do, we would square both sides because we want to get y by itself. So it's a squared is equal to y. So basically, it'll be the s inverse should be, well, s inverse, or just, yeah, they did s inverse, is equal to a squared. So basically what we have to do here is just put y is equal to x squared. Now, I want you to look at this. This actually does not, well, let me expand this out. Okay, this actually does not look like inverses of each other because this is a parabola. Now, the reason why this is an inverse is because in the context of this situation, since we're doing measurement, we do not have negative values. So basically, all of these values over here would leave. They're actually of no use. All of the negative x values is of no use. Okay, so with that being said, let's take a look at the table. I'm going to do both. Okay, now, if we look here, 0, 0, 1, 1, And then if we look here, you notice with the negatives, they would be undefined. And remember, in the context of this problem, we're not using the negative values. So watch this here. Let me put on another value here. Let's put 9. Okay, we had 9, 3. So that means down here it would have to be 3, 9, which it is. We could try one more. Let's try 16, and it's 16, 4. So down here it should be 4, 16, which it is. Okay. So now we prove that this is an inverse function. Now we have to ignore, the negative part, like I said. Okay, now it says, for B, it says check your graph of F inverse using the draw. Okay, don't worry about that. They were talking about using the TI calculator, so don't worry about that portion. Okay, so now we go here to C. It says, what are input and output variables for F? Okay. So basically, the area of the square is the input. The area of the square is the input, which is x. So you know the area of a square is never going to be negative. The length of the side of the square is the output. Okay, now we come here to D. It says, what are the input and output variables of F inverse? So basically, it's the same thing, just rewritten. So basically, the length of the side, let me write that out. So for D, the length of the side of the square is the input, and then the area of the square is the output. Sorry about that. I guess this paper is starting to curl up. Okay, now E. Would F inverse ever be useful in this situation? Yeah, it would be. That's if we're given the length of the side, we can determine the area of the granite top. So given the length of the side, we could determine the area of the granite top. So that's how it could be useful. So basically we are done, and if you all have any questions, feel free to ask at any time. Just let me know.